All right, so projector's not working. Stephanie's going to go try to find. Does anyone have an HDMI to VGA converter? Right, he's going to go try to find one. In the meantime, let's hope you have a lot of questions. So you're working on PS8, right? It's due Thursday or Friday. Take a late day. How's it going? Questions? Yeah. That's right. It's due Friday or Saturday. Yeah.
So I understand how we're supposed to manage the time remaining. So if I start a game like on the client side, and it has like a 1 minute time limit, that should start counting down.
Right.
If there's a delay between it going to the server and then the server creating the game, it'll send back like another one that says like what the time limit was, the time remaining. But there could be like a second or two difference in between those two.
Well, basically the server does all the timing. So when you start a game, the server starts a timer. And every time you ask for a status update, it'll tell you the score and it'll tell you how much time is left. And when time runs out, it'll stop accepting new words. And if you ask it how much time is left, it'll tell you 0. So to keep the your client display updated with the current time left and the current score, you're going to need to periodically contact the server and ask for status. And it will, when you get back the score and the time, you can display that. Now, you're right, it may be a little bit off because of lag, but we're not going to worry about that. So the game may end technically when there's a second left shown by the client, but that's just the way it goes. Got working a whole lot harder. Yeah?
So I ran into a problem when I was using JSON convert to deserialize the object that I'd gotten back. In your examples, you had just typecasted that to a string, but in mine it was giving me an error saying that wasn't compatible, and so I got around it by deserializing it into an expando object, and then just getting the property like user token from that. But I was wondering if you know why that problem might be coming out.
So my first question is, do you have the NewtonSoft package installed in Visual Studio?
Yes.
Okay, so let me just elaborate on that. So the converter, the part of the code that converts, that serializes and deserializes strings to JSON is provided by a third-party package, NewtonSoft. And if you don't have that already, what you need to do is right-click on your project, and there'll be an entry called Manage NuGet Packages. And click on the Browse tab, and I think the first thing that shows up on the most popular package they have is NewtonSoft. So install that into the project. Beyond that, I need to look at your code to know what's going on.
I got a comment on that. So a lot of people, if you look at the REST example that we provided, we deserialize the objects and we store it in like this dynamic thing, which is just essentially just a chunk of memory. And the thing is, so if you have multiple things in the return from the API, it's going to be stored in an object. So you need to go like to each property within the object. You can't just cast the entire object into a string because the whole object is not a string. Right? Does that make sense?
Yeah.
So you have to go to the object, and then you'll do like dot user token, and then you can cast that into a string. So does that answer your question?
Yeah.
So let me elaborate on the elaboration. In the to-do list server, there are a couple of calls that are made that return strings. Okay? They don't return JSON objects; they return JSON strings. That is not the case with the Boggle server. There is no REST call you can get that returns anything other than an object. And so if you're not converting it to an object, you're trying to use it directly in some fashion, you're going to have trouble. So it's objects, and objects have properties. And the properties could be strings or other objects or arrays, lists rather. So you need to use them, access it that way. Be sure you understand the API. Yeah?
Isn't it due on Friday?
Yeah. Yes?
In the example REST call using a cancellation token you're sending,
Mhm.
could you explain a little bit about what's the intended use of those?
Well, a cancellation token is just a technique that .NET provides to cancel, it provides a way to cancel things that may potentially take a long time. So all the methods like post async, get async, put async, delete async, take as one of its parameters, at least in one of the overloads, takes a cancellation token. And it basically looks at that cancellation token periodically, and if the token has been canceled, that results in that async call being canceled. And what will happen, instead of that method returning, an exception will be thrown back at the point of call. In your own code, it was illustrated a couple of weeks ago in another context, but your own code can examine the token and know when to cancel itself if you wish.
And do we need a unique token for each type of call we're making, or can we just use one token for everything?
Well, I think
Restore.
you could use one token, but the problem is once it's canceled, it's canceled. So you can't reuse a token after you have canceled it. So you have to be careful about that. Other questions? Anybody know any good jokes? Yeah.
To clarify, to make sure that I'm understanding the specifications correctly, we don't need to show a live score update as the game continues, but only show it at the end.
No, you need to show the live score update continuously,
Glad I asked.
right? And since you'll be getting the score from the same place you get the time, it's really not a big deal. Now, I want to point something out. Your client is going to need to periodically contact the server, probably every second. That'd be a good thing, to contact the server every second to get an updated time and updated score to display. Do not write a loop that says, while true, contact server. Okay, that's called a denial of service attack. If one of you does that, everyone else is hosed. Okay? It'll bring the server to its knees. You may contact the server at most once per second. The right way to write that kind of loop is with a timer. So you can find a timer object which will call a delegate every second. You can set up a timer to call a delegate every second. That's the right way to do it. You don't even have to write a loop. You just say, call this every second, you're done with it. And every second the update happens, and you turn that timer off when the game time expires. Yes?
I missed something somewhere, I'm not sure. Is there, like in the status object that's returned, is player 1, player 2, is there any designation like which player is 1 and 2?
I believe it contains the ID of the player.
On some of them it doesn't contain the nickname of the score, but in others it just contains the score.
Okay, well, so there are various forms of this update you can get, the status you can get. And so if you need to know who is who, you can call the version of status that gives you what you need to know.
Okay.
It's designed so that most of the time you just need to ask it for the time of the score. Yeah.
For clarification on the scores, do you mean like you want to always update both player scores or just the whoever's interacting?
Both player scores. You want to see the previous game. You don't display all the words.
Sure, but you want to see like
I want to see how I'm doing. Right.
or something.
Am I winning or losing? Yeah.
So when player 1 creates the game and returns the game code, how does player 2 then input that same code?
Player, okay, so you're talking about joining a game?
Yeah.
You don't. When there's a join game, and so when you join a game, if you're the first one, it sets up a pending game.
Okay.
And then when the second player comes along and has to join the game, you don't supply the game ID, you just say, pair me in a game, and if you're the second person, you get paired with the other players.
Oh, okay.
Yeah.
Okay, so I think I misunderstood the way that the games are operated. You keep on rolling the bongo dice, and you keep on submitting your words and incrementing your score until the time runs out.
No. You don't roll any die at all.
You know,
The server tells you what the board is.
Okay, well, you get the values then, you get the values, what those boards are, and you submit a string that would be, and then they calculate the score and all that.
Right. So
Keep on doing that.
yeah, while the game is in progress, your client should be every second updating the score and the time left. And then every time you enter a word, your client needs to send the word to the server. That's what it needs to do, is send the word to the server. And the server decides if it's right or not, what the new score is. It's up to the server. So you just need, once the game starts until it ends, you're just sending words and asking for updates. Okay? Other questions? Okay. Well, yes.
You're using game status to update the player word lists and scores, right? Or are you using the play word? The play word also responds with the scores.
Well, play word will tell you what that word was worth.
Should you be using that to update?
Well, you could, but you need to be calling game status anyway to find out if your opponent's score has changed. So it's simpler just to rely on the game status to
So
update
can you
your
just
score.
kind of disregard that it sends back the scores?
Yeah, you can just disregard the return value if you want. Might as well. Yeah.
All right, so if I create a game with desired length 30, and my partner tries to join, or someone else tries to join a game with a different desired game length, how does that handle?
It says that it averages.
Oh, cool.
Seems fair. Yeah.
So it averages the full scores, and then how do you know what the, it's updated?
And also, when you join a game, okay, you ask to join a game, you may end up waiting for a while to be paired with someone. So that's another case where you're going to have to ping the server and say, has the game started yet? Has the game started yet? It's another good thing to only do once a second. It's an open question how well the server I have is going to work, because I've always deployed it in the past on Microsoft's Azure cloud, and now it's running on a local machine, and I don't really know how they compare. So we'll see once it's Friday night and everyone's working at the same time how well it holds up. I would recommend getting done sooner. Okay. I have been teaching for so long that I remember when there were no projectors, and in fact, when I started teaching, there were no such thing as laptops. I can remember having a whole computer stored in these desks, these tables, so that we could, when we first had projectors, so we could project something. So I have lots of experience teaching in chalk, and that's what I've been reduced to today. So I can't do everything that I plan to do, but I don't want to completely waste the time. So I'm going to do my best here. So if you can see my slides, let me take me a second. My slides are typically my notes. And maybe Stefan will come back with a converter for me. Let me just explain. So you're busily working on your clients, but now I've got to teach how to create a server, because that's the next assignment. That'll come at the end of this week. It'll be in 2 weeks. We'll be doing 2 weeks, since there's a spring break in the middle. So you'll have your client by then. So you'll write a server that works pretty much like the server of mine that you're using right now. So to do that, you've got to have somewhere to deploy your server. You've got to have a web server to put your service on. Let me be the only one that talks. I appreciate it. Thank you. Fortunately, Windows comes with a web server. It's called IIS Express. So it's just sort of a stripped down, faster version of IIS. Okay? And so that's when you're testing your servers, you'll be testing them locally on your machine. Now, eventually we'll have a lab where you take your servers, your working servers, and push them up to the cloud and run them on an Azure, in the Azure cloud somewhere out there. And that's really not much more than clicking on a few buttons in Visual Studio to get it deployed once you have an account on Azure. But for now, we're working locally. So that's our HTTP server. What you'll create is a type of project called Wcf. So inside Visual Studio, you'll create a Wcf project. I don't even know what that stands for. Anyone know? Windows something Foundation. I don't know. Anyway, Wcf project. Now that project is designed for deploying services. Unfortunately, it does not seem to be designed to easily deploy REST services. They seem to want to deploy XML-based services with it. And so it takes a bit of configuring to make it do REST. And I've done that configuring, of course, in the to-do list server that I gave you that I was going to show you today. And I've done that configuring in the Boggle service that you're using. And you're welcome to try to do that configuring yourself. My recommendation is that rather than try to change the configuration files to make it into a REST server, that you just take my to-do list service and use that as a starting point and just rename things appropriately. Okay? Just be sure you rename things with Visual Studio. You don't go off outside of Visual Studio and start trying to rename things. That's when things go bad. So that's my suggestion for that. What do you suppose you'll have to do now? You've got a web server that you can put files on it and serve it back, and you've got this project. What are you going to have to put into the project other than these configuration files? What's it going to take? What kind of code are you going to have to write? Yeah.
One of the more complicated problems I was thinking would be figuring out whether valid words based on the board.
Okay, so you're talking about valid words based on the board.
Yeah.
Okay, that's way in the back end.
Okay.
I'm more concerned with the web part of it. Because I'm actually going to give you part of the code, the code that actually determines if a word is legal. I'm going to give you code for that. I want you to focus on the web interface. Yeah.
Probably need something equivalent to in C# world as a servlet to accept and handle these REST calls.
Okay, so something to accept and handle the REST calls. So the API for Boggle server, it has what? 6 or, I don't know, anyone count 6 endpoints? You can register, you can join a game, you can cancel a game, you can play a word, you can get an update, maybe only 5. So somehow you're going to have to write code that runs on the server that notices when a request comes into the server. And then what's it going to have to do when that HTTP request comes in? When it recognizes, this is a register call, or this is a get status call. What's your code going to have to do? Yeah?
Deserialize the JSON object and send a response.
Okay, so he said deserialize the JSON object and send a response. So basically, it's got to take that request apart. It's got to look first at the URL, because there may be information. Some of those calls has information buried in the URL. So you have to take the URL apart and figure out, okay, what game ID is this pertaining to? There may be some optional parameters in the URL you've got to pull out. In the body, there'll be a JSON object. You'll have to grab that from the request body and deserialize it to a JSON object. So you're going to have to extract a bunch of information from the URL. So once you've extracted the information, what do? So you've got the object, you've got the game ID, you've got the optional parameters, you know what request is being made. Any ideas? Yeah?
Return a status code.
Well, before you can return a status code, what do you do with the information that came in? Yeah?
Probably forward it to an appropriate service that can handle it.
Okay, so you've got to take that information and do the computation. It's basically a method call being made over the web. So you take the request apart in order to create parameters to a method, which then computes the answer. The answer being in the form of a JSON object. So you need to take the input, create the result, convert the result into a JSON object, and then that's when you specify a response code, you generate the response that contains the JSON object, and you send it back. So a request comes in, request goes out. Now the low-level details of receiving requests and sending them back are handled by IIS. You don't have to worry about that. You're not worried about the networking part. You're just worried about taking a request as it comes in and taking it apart and producing the response. So let's look at the kind of code you're going to have to write. Now, I'm sort of skipping around here in what I wanted to show you to try to get something that works. On the board. Okay, let me show you this first one. So you're going to, first of all, you're going to create a file containing interfaces. A file containing an interface. And each thing in the interface is going to be a method that corresponds to one of the endpoints in the API. So if there are 5 API endpoints, there are going to be 5 methods. All right? And let me just show you an example of one here. So let's say you have, I want to make a little bit of room here. Let's say you have a method called this. So we know that before you can use, this is an example of what would be required for the to-do list server. So we know that the to-do list service provides a way for you to register, right? There's a post request you can make that says register me as a user. And what goes along in the body of the request is information about the user, name and email. So on the server side, we're going to declare a method called register. You can call it whatever you want. That takes as a parameter a user info object. And then we annotate it. We annotate it like this. We're out of room here. Okay. So you can have this special file that will contain an interface. It'll contain a method for each endpoint. And the annotation is what connects what's coming in the form of web requests to this method. So look at this annotation and tell me what information is in there. How would the server make use of this annotation? How would IIS make use of this annotation? Yeah?
The type of request that you're posting.
Okay. It says use this method right here when a post request comes in. And what's the use of this here?
That's the endpoint. So you're
Right.
going to register a user.
If the URL should end with register user. So if we get a register user request, that's a post, call this method. That's what we're telling this, essentially what we're telling the server to do for us. Now, what about, does any request that comes into the server that ends with /register result in a call to this register method? Why not? What do you think? Yeah?
Does it depend on post, the method we're invoking, like post, put?
Well, this seems to be saying that if a post comes in that ends with /register user, call this method. But in fact, not any post request that ends with /register user will result in this call. Which ones will? No? What determines which ones? Yeah?
Are you talking about this being just in an interface? You know, it's the class that
No, it's not that. Typically, a server is, you can have many different programs, many different services running on a single server. There may be some other service somewhere on the server that also has a register user endpoint. So how does it determine which service gets to see this REST call? Well, what would you type? What URL would you use to invoke the service? What would you use from your client?
The register button?
What's that?
A register button or something?
Well, it starts with an H. Yeah?
The base address.
Right. You would say something like, okay, HTTP:// your service will be running on localhost. And I think mine was maybe running on port 50,000 my to-do list. That was just part of the agreement. And then you say to-do.svc, which is the name of my service. And then you say register user. That would be the full URL. You would make a post request with that URL if you wanted to invoke my register method. How does the server make use of this whole URL to route that call to this method? So IIS is going to look at that and say, this service is interested in that. Yeah?
You need a router class to get to the right methods.
No, we don't need any. We don't have to write any code. What you got?
Can't find a converter, but got the next best thing. See what I can do.
Okay. Sorry. All right. I'll talk while you write where you were. Yeah.
Using the to-do.svc part of the address?
Right. What will happen is when you configure your server, your service, you will say it's going to be, if you want to invoke my service, it needs to start with that URL. So this URL will be in the configuration file. You will specify this in the configuration file. And then that's part of your configuration as well. So the server looks at everything up to here and says, that's Joe's to-do list service. Okay? If there were a different URL at the beginning, it would say, that's someone else's service. So the server looks at this to decide where to route the request. And so if everything matches up to here, it calls the register user. It'll call the register user method. Now, so back over here. So it just happens to a register user gets called. I mean, the URL coming in matches this. It's a post request. That method gets called. What's the parameter to that method? What is a user info object? Right. It automatically for you. So this, you don't have to do anything. It knows this is a post request. There's one parameter. That parameter has to be a JSON object in the body of the request. It automatically takes that object out, deserializes it into a user info object, and calls the method for you. So you don't have to do any of the deserializing. You don't have to do the taking apart of the request at all. You just got to write this little bit of configuration, and it automatically calls your method with the deserialized object as a parameter. All you have to do is declare user info. So what do you suppose that the user info object is looking at? Somewhere you've got to declare user info and essentially put properties into it. What properties do you think the user info object needs to have in it? Yeah?
Nickname.
Okay. So one thing is the nickname. So there'll be like public, string, nickname. So you'll have a property called nickname. And what else will it have? Email, right? Those are the two parts of it, that's what's coming in. So then there'll be public string email. That's looking promising. So you declare that object, because you're expecting the JSON object that comes in to have nickname and email fields. So you declare an object like that. You write this.
He fixed it.
And there it is. Thank you.
Well, I told you it's not broken. It's not your fault.
Well, I didn't think it was my fault. Okay. You broke it again.
Oh, going through the splitter.
There we go.
Okay. Thank you so much. Okay. So this is actually what we were talking about here. And yet, people screw this up all the time. Okay? I do not know why, but this which seems so simple gets just corrupted into the weirdest things by the time the project is over, the assignment is over. Let me tell you one mistake people make. They might take this thing here, register, and they decide, you know, instead of having a user info parameter with a, an object that has a nickname property and an email property, heck with that. I want it to have two parameters, a string which is a nickname and a string which is an email. And so they do that. The URI, that template stays the same, but register, they just write to take two parameters instead of one. That won't work. Why won't that work? Yeah?
That's not what the client will send.
The client will send an object. There can only be one parameter. It can't be two. Where would the second parameter come from? The parameter to register is the body of the request. So you don't have any choice in the matter. There's just one parameter, yeah.
So, I believe in JSON you can have like a list or collection of objects.
Mm-hmm.
You just declare that with the list interface, that one parameter.
Yeah, you could just say, if you're expecting a list of things in the body of your response, suppose you're expecting a list of user infos, you would just say list of user info. And it deserializes that for you. But you can't tweak the parameter list of register to your heart's content. It has to match up with reality, and the reality is there's only one parameter available, namely the body of the request. You can't ask for more than one. And the one you ask for, it better have a type that has, it better be an object that has the right types of fields, a name and a nickname. Okay? Okay, we'll take like a 2-minute break, since I've been going slowly anyway. Get this audio visual set up and then we'll finish up. Are you getting the input? Okay, so like I was saying, Wcf Service Project is what you're creating. To run it, you need to, you may have multiple projects. You make the service project your startup project. In the past, there was some flaky thing where you had to make sure that the project was selected as Solution Explorer. It may or may not be true anymore because of the upgrade to Visual Studio. And then you run your application like a regular application. Just click the run button. So let me show you what that looks like. So here we have, this is my to-do list server. You can see I have, there's a bunch of stuff in it. But if I want to run it, I just make sure it's a startup project. I click this button, which now says Firefox, for a reason you'll see in a second. I click it, and up pops a web browser that contains my API. Now I arranged for that to happen. So the expectation is that when you run it, it'll bring up a web browser, I guess, so you can interact with the service. Now, there are configuration options. So let me go back to go back to here and show you. Let me stop the service now. Now it's no longer running. If I right-click on the project and I go to Properties, no, that's not right. Right-click on the property and go to Property, on the project and go to Properties. Here are these web options. And one thing you can do, it says Start Action. So you can decide what does it show when it starts. So I specify when it starts, it should display help/index.html, which is my API. Another common thing is just to do this. Just say, don't open a page. I'm going to interact it with the client. I don't want to, you don't have to start a browser for me when I start the thing. So that's usually what I do, really, is I just say, don't open a page. So I don't want to see the browser pop up when I start the server. Okay, so I'll save that. So that's one bit of configuration you have to do. Now, let's see what else is in here. You need to, right here under project URL, you need to specify the URL for your project. And so we're running on http://localhost:/port 44444. That's how I have it set up here. So you need to pick a port. You know, just pick a 5-digit number. In fact, I'll tell you what number to use. But you need to specify that as the port so that when requests come in to that port, they can be associated with your program. And the other thing you have to do is once you've picked a port, once you've done all that, you need to click on that button right there to create virtual directory. That's essentially how you publish your project, your server, to IIS. You click that, and then that writes a file that IIS looks at so that it knows what port you're listening to. It registers your service with IIS. So you're going to do that once, not twice. One thing that really gets screwed up is when you publish something twice and there's multiple entries, suddenly it's unclear which version is running when you try to run something, and it seems to be running old versions of your code, and in fact it is. So just do that once. So that's a bit of configuration you have to do. Okay? I mentioned there's other configuration. So here's this, you see right there, todo.svc. That's the actual service. And it has both a configuration, so I can go here and look at view markup. And that's what I see. So that's created for you automatically, but when things go wrong, it's good to look at that and make sure that it makes sense. That's just saying that the name of the service is todolist.todo. To-do list is a package name. To-do is the first part of todo.svc. And that the code that's actually run for the service is todo.svc.cs. So I'm just showing you this so you know places to check when things get misconfigured, which sometimes they do. Okay, so we got that. Then we have this file web.config, which contains all kinds of stuff. This is what I'm saying. It's best just to start with my service as a starting point and rename things rather than try to create this from scratch. For some reason that doesn't want to work for me. I'm having all kinds of trouble. Okay, let's just glance at the config file. Oh, come on. Okay, it's restarting. I'll just wait for it. Okay, so we're in examples S18, to-do list server.sln, and web.config. I want to take that out here and make it large. So, you know, that's quite a bit of configuration that you don't want to type in by hand. Okay? So, if you start with my project as a starting point, you won't have to. You can see it's referencing your servers in here. So you don't want to come in here and edit the config file. You just want to rename things in your project so that they have the right names in here. One note, this is in the slides as well. This little section is worth looking at. If you set these three things to true, then you get more debugging information out. If you access this thing through a browser, you get more information out than if you set them to false. So the idea is set them to true for development, then set them to false for release. You don't want, when you put something out for release, you don't want it to be seeing debugging information. You have your customer seeing debugging information. But for development, it's good to set those to true. Okay, so we got this mysterious configuration file. And I think that's enough configuration advice for the moment. Let's dig into the code. So this is what I was talking about. There is, remember we have to-do list .svc as our service. I have created an interface called I-to-do. That's the interface of my service. And there's the register method we were talking about. So let's go through and look at the service interfaces. So we explained what register meant. Let's look at add item. So add item, here's the annotation. It says if there's a post call and ends with /add item, invoke this method. Now, what's wrong with that? What is wrong with the add item method? Yeah?
2 parameters.
2 parameters. Where's the second parameter come from? Notice, no error. There's no red. The compiler is not going to report this as an error. The error is not noticed until you run the program. And then at that point, it can be hard to find out what's going on. So don't do that. So I'm going to take that out of here. Okay. So basically, if the add item URL comes into the server, it results in this method being called with a deserialized version of the whatever came in the response in the request body, just like with the post up there. Very straightforward. Now look at this one here. This is my the method you use to mark an item complete. The method is put. The URI template is /markComplete, it's /item ID in braces. What's going on here? Yeah?
The information is sent with the URI template?
Yeah, if you remember the way we organized this method, there is no body, there is no object in the body of this request. We're just asking, we're giving an item ID and asking it to be marked completed. And so the actual item ID comes in the URL. So if you want to mark item 12 completed, you would do /markCompleted /12. So when you put this little bit, this kind of syntax in that annotation, what you're saying is, when the URL comes in, pull out the number, the thing that comes after that slash, and pass it as this parameter. Now, how does it know that there's a correspondence between whatever is in the URL there and whatever in this parameter right here? Same name. Item ID, item ID. If you decide you don't want to call this item ID, you can change it, but you better change it up there too. Otherwise, there's not going to be that correspondence. You know, if I go up here and change this somehow, there's still no error. But it's going to be an error when we try to run the program. So those have to correspond. So the request comes in, it pulls the number, or the string, out of that part of the URL, passes it to this method, and whatever comes back gets serialized and sent back as the response. So this configuration is absolutely critical. And like I say, it's a real source of errors and headaches for students. Yeah?
What's the difference between sending strings in the URL rather than sending them in the body?
What's the difference? You could do it either way. You look at a serious, this isn't exactly a serious service. You look at GitHub, and some things they prefer to send in the URL as parameters. Some things they prefer to send in the body. It's just a matter of, I'm sure they have a reason for it. It's just an option. All right. Here is our get all items thing. So this is a get. Oh, let's look at the delete first. Okay, this was the delete. This is how you delete an item. And again, the same thing. There's item ID in the URL, and there it is as a parameter. Here is the get all items. And look right here at the URL pattern. What do you notice? Yeah? There's two optional parameters here, completed only and user ID. They're named down here. So whatever shows up here will be extracted and passed as that parameter. And by the way, it better be true or false. And whatever shows up here is extracted and put there. And if you don't provide those parameters, these don't have to be there. So if they're not there, it uses a default value. Probably null here, false there. Yeah.
So just want to be clear, the question mark before completed indicates that they're both optional.
Well, question mark is how you indicate that now comes the query part.
I just didn't notice on the delete method.
No, this is the only place we use this. This is just common usage in URLs. If you want to send parameters in a URL, one way to do it is this way. What makes it optional is we said they're optional. You're not forced to supply them. Let me do one more little change here. What if up here we wanted to have we wanted to have two parameters. Suppose we wanted to have something like this: register user, and for some number, for some reason we wanted to have a serial number up here. And so we did this. Okay? Would that work? What would happen when the register method is called now? When the register endpoint is called? We do register user /17. Are we okay, or are we going to have a problem? Yeah?
Doesn't it depend on this, whether the server has that integer serial as well, or are we assuming it's there as well?
Oh, I don't know what the serial means. I just want to know, is there going to be a mismatch between, how does this parameter list determined? How does the information that comes in the request get mapped to the two parameters of the register method? Yeah?
It will take the serial out of the parameter or the URL and send it to the serial. Or deserialize this JSON object for user info. So
Right.
it should work.
This is the rule. This will work. The idea is you can have two parameters even though it's a post. But all but one of the parameters had better be named up in the URL. The one that's left over is the one that gets the body as its value. So whatever is in the URL up there will be passed as this parameter, and then what's in the body of the request will be put in that parameter. So yeah, that's okay to do. And I think there are cases in the Boggle API where you'll need to do that. So let me just emphasize again, you got to be careful here. This is supposed to make things easy for you. It's supposed to make life easy because you don't have to do any serializing, you don't have to do any deserializing, you don't have to pull URLs apart. It's done for you, but only if you get this right. If you get it wrong, you won't find out about it until you run the program, and even then you might not find out about it. Something just won't work and you won't know why. And so you'll post a request to Piazza and someone will say, you screwed up your interface. Okay? So skip that cycle and just get it right the first time. Let's run this and see what happens. So I'm going to get rid of that. I want to make sure that my this is the actual implementation. Let me look at this first. This is the actual implementation here. Of that implementation. So you can see, I won't look at how I'm doing it right now, but I have a register method with the user info. I have the add item with that bogus count parameter I want to delete. So these are just implementations of those methods that were declared in the interface. So that once you've declared them, you can come here, you can fire up the server, Now the server is running. If you had a client, you could run the client, or if you don't, good thing to way to test your server at first is to use the advanced REST client. So here I have the advanced REST client. I've got it already set up to register a user. I say send, and back comes a 201, so that worked. Okay? So we've experimented with this before, so we can, you can experiment with the service this way. Now, I'm going to show you what goes wrong. I think showing you what goes wrong is more important than showing you what goes right. So I'm going to stop the server. I'm going to go to this. I'm going to go put back in the bogus count. Okay? I'm going to go back to the interface. I'm going to put in the bogus count. Done. I'm going to run my, so no compilation problems. I'm going to run the service. Well, I got rid of that. Okay? Service is running. I can go to the advanced REST client. I can send that register user. And I get a 500 system service model.service activation exception. Oh dear, something went wrong. I go look down on the response headers, and there is precious little information about what went wrong. I dare say you're not going to figure out what went wrong. What went wrong is that interface is misconfigured. And so I guarantee you, we can keep count. How many times the week after spring break someone says that I'm getting a 500 system service model.service activation exception? That is, if you see that, think misconfigured. Now, this is something I discovered today. Let me issue this request. This is the get all items request. Now that should be unaffected, right? Because I didn't misconfigure get all items. So let me send that and see what I get back. I get an internal server error. So I'm hosed. I've misconfigured one bit, but it hoses the entire service. But this is cool. For some reason, I get a lot more information back with the get than I did with the post. So I'm going to look at it here, and it says register of contract I to do specifies multiple request body parameters to be serialized without any wrapper element. So basically, it's pointing you at the problem. So sometimes you get lucky, sometimes you don't. Okay, but it can be really confounding to have a configuration problem show up when you're not expecting it. Let's go back in here. Let's see if what I said was accurate. Let's do this. So rather than get rid of that bogus parameter, let's just make it legal. Now I'm expecting count in the URL. Let's see let me start the server up. Let me go to here. Let me go to the register user call, and let me add 55 there, so I'm passing the parameter, and hopefully this won't make a liar out of me. Oh, now I get information. Multi-request body parameter to be serialized. Okay, I guess I was wrong about being able to do that. Now, hold on. Okay. Scratch that idea. Let's go back to what works. So we'll change the service. We'll change this. Okay, so there's building that interface. That's the first crucial thing in getting that right. Then there's the problem of implementing the service itself. Yeah.
When you put in count to that, does it automatically know that it'll be an integer, or should it be a string?
I declared it to be an int, so it should. I expected it to be cast to an int because it was declared as an int. I don't have time to debug what I did wrong there. I know it's possible to extract an extra parameter. I screwed something else up. Okay, so you got the interface going. And to remind you, what happened to this guy? When when I created this project, create the service, if you look at the markup for the service, this is where it mentions the name of the service and the name of the code. And that ties it to the interface as well. Let's look at the actual implementation, todoservice.cs. This is the implementation of the service. You'll be doing something similar to this for the Boggle server. Let's see. I want you to look at this and tell me what I did wrong. I did something here I told you never to do. Yeah?
Declared static.
I declared static, since rather than having instance variables, I have static variables. Now, I did that deliberately. Let me explain why. If you make them instance variables, there will be one, this is a dictionary that keeps track of user information. This is a dictionary that keeps track of the items in the to-do list. So that's the state of the to-do list in those dictionaries. The methods manipulate those dictionaries. If I made them non-static, every time a to-do list, a to-do object is created, it'll have its own dictionaries. And the server can, when the server gets a request in, it needs to service. It has the option of either using an existing to-do object that is created in the past, or creating another one and using it. We don't have any control over that. It might want to do that, it might have multiple cores at its disposal, so it wants to have multiple objects and run them on separate cores. Why would that be a disaster for us? If each instance of the to-do object had separate copies of these dictionaries. Yeah?
Does one request might turn one to-do list, and then you make another request later, it might be completely different?
Right. You add an item to a to-do list, it gets stuck in this object's dictionary, and then the next call results in another object's dictionary being looked at, and they're inconsistent. We just want there to be one set of dictionaries, one pair of dictionaries for the entire service. So we make them static. Okay? Now we got a problem. There could still be two requests going on at the same time and running in parallel. We could have a multi-core server that gets two requests at about the same time. It calls them, they run on separate threads, and they're both trying to modify the same dictionary. That's bad. How do we fix that problem? Yes, Bruce.
You put a lock around it?
Right. We have to put locks. We have to synchronize access to these dictionaries. So I create that object for that purpose. So if you come look at all the methods down here, first thing I do is I set a lock, and then I do what I want to do. I set a lock, and then I do what I want to do. Now, I call this a poor man's database. What we really want to do is get rid of those dictionaries and put all the state of the application of the service into a database. Databases are good at managing concurrent access. Have lots of advantages. But it's too much of a step when you write your service as PS9, that's it, to have to learn about databases at the same time. So for your assignment, for PS9, I want you to put your entire state into static variables and be sure to synchronize access to them so they don't get corrupted by multiple threads. And for PS10, we'll remove these, replace them with a reference to a database. And we'll see about putting data keeping the data in the database instead of these dictionaries. So this is just a poor substitute for a database. Why is it such a poor substitute? Can you see a real serious problem with storing the state of your application into these dictionary objects? Yeah?
Your objects get really big, that's going to slow down the service.
True, the objects would get really big, and databases are good at scaling. They're really good, but that's not even the worst problem. Yeah.
You lose all your state when the server shuts down.
Right, when the server shuts down, your state's gone. Database, it would be there permanently. So that's why we want to use a database. But it's just, like I say, it's too big of a step. So I declared these objects to contain all the state I need to contain. And let's just look at a typical method, like register. Okay? register is getting a user info object, and the user info object has things like, has various properties. If the username is stall, that's where I put this feature in, to just stall the server for 5 seconds so you can do testing. Otherwise, if the username is null or if the username is empty, I set the response status to forbidden and return immediately. So that will send back like a 403 response code or something. That's just what the API says to do. Otherwise, if everything's legal, I create a new user ID. I add the user object that came in to my users dictionary with the user ID as the key. I set the status to created, so that my response code will be 201, and then I return the user ID because I'm supposed to return a string. And the server takes care of the rest. It takes care of putting it to the response body and sending it back. I just got to compute the right response, set the status, and return the response. And this pattern is followed by every one of these methods. So let's look at add item. We set a lock. If any of the values are bad, we set the status forbidden and return null. Otherwise, we compute the answer, which is this item ID. Set the status to created return. Notice it's all done inside of a lock. Here is mark completed. We take the item ID, we look it up in our table. If it's not there, we respond with forbidden. Otherwise, we mark it as completed in our database and set the status to OK. So no serialization. You don't have to mention the word JSON in here. Everything's C# objects. And there's delete item. The most complex is get all items because it has to return a list of to-do items. So it just builds the list and returns it. And it gets serialized on the way out the door. So they're setting the project up at first, which I recommend you do by taking my to-do list project and renaming stuff, deleting stuff you don't need, going from there. Then it's a matter of creating that interface so it's correct, so everything's annotated correctly. Then you just write methods. You're just in C#. Now I'm going to go back to the slides and show you a few things I want to highlight. Let's see if there are any questions right here before I do that. Yeah?
So where you were doing the sleep for 5 seconds inside of the lock, that would prevent any other instances?
Yeah, that's a really bad thing to do. While you're sleeping, no other clients would be able to make progress either. They're all being blocked. So it's a terrible thing to do on many levels, but it's just there so you can test your cancellation code, essentially. All right. So a few things I want to point out. And again, the challenge is you're worried about clients right now, not servers. I get that. But I got to do this now so you can get started on it after spring break. So, let's see what we got here. All right, these slides are mainly for you to refer to later. This is talking about what, the server stuff, which we've talked about. This was reminding you what the API was like. This shows you the 5 endpoints in the API that we've been looking at. So you look back at this, that's what it's for. We talked about what a Wcf Service Project is. That's the kind of project you create to deploy a service. I recommend that you start from mine and refactor it, as opposed to starting from scratch and trying to create that file. When you look at the service in the Solution Explorer, you will see, of course, the project. That's the Wcf project. You will see the service interface, which is that itodo.cs. You will see the actual service definition, which is to-do.svc. And there are 2 parts of that. There's a beta configuration, there's the markup, and there's the markup piece, which isn't shown there explicitly, and there's the code piece, which is that. That's the actual implementation of your service. And then this web.config file. All right? If you look in the web.config file, you will see that it refers to the project in several places. So it refers to the interface right here, and it refers to the actual service project right there, the SVC part. Those will get, if you rename the service, this will get renamed automatically back here in the configuration file. So you don't have to go muck with this. Just use C#, use Visual Studio to rename the services inside of Visual Studio. There's other stuff in the config file. This is just a snippet. There's other stuff that needs to be done right as well. This is another place where I was just mentioning, these are the ones you want to set to true. Make sure they're set to true for debugging purposes. You get more information out. If you look at the project properties, remember we talked about this, you can choose what to happen when you start your service. You can choose it to display a web page, or you can just say don't open a page, which is what I generally do. Also, down here is where, this service is listening on port 44444. What port does the boggle service listen on? It has to be built into your client, so it's at least something that some of you want to know. I can't remember. Let's say it's 60,000. I don't know what it is. So you would change this to 60,000. And then you would click Create Virtual Directory, which that lets IIS know about your project to serve it. Okay, now, I forget this every year, that one way to screw up is to publish, is to click that button on the last slide more than once. So, when you click that button, what is happening is there's a file called applicationhost.config that is hidden pretty well. And to find it, you've got to go to your project. So we'll go to the project here, and we will open the containing folder. So you go to the project, which is, there's to-do list server. Actually, you go to the actual solution. There's a .vs file. Double click on the .vs folder, then there's a config folder, and then there's applicationhost.config. So the slide tells you where to find it. If you go to that applicationhost.config and drill down inside it, you will see an entry called sites. So there's one site. That's the default one that comes with the config file. This is the first time I clicked that button, and it created a to-do list site. Then I clicked it again, and then I clicked it again. So I succeeded in creating 3 different sites, all serving the same thing on different ports, 444, 555, and 50,000. And I remember I was getting frustrated because nothing would work right. So if you mess up and your server just isn't knowing where your code is, you can come in here and carefully just delete. If I were to delete all these sites right here, those 3 to-do list sites, now IIS no longer knows about my service. If I start the service, so I've removed its notion, so if I start the service, it'll start just fine. I don't know what that is. Oh well. Maybe it won't start just fine. What I expected to happen is I would start it, but it wouldn't respond in the browser. How would I fix that? I need to create that virtual. I need to go here, right-click on the project, look at project properties, go to the web tab. That's where I've set the URL, right up here. What the heck? It's been a tough day. Oh, project, okay, so I even got deleted. http://localhost 4444. So that's the URL, and God, something's all screwed up now. There's supposed to be a button there to create the virtual folder, but it's the directory. It's not there at all. Huh? Not my day. Anyway, that's where you would fix it. Okay? So that's the application host config file to look at when things go wrong. These slides talk about the service interface. So a lot of the stuff that I talked about, you're going to find sitting in those slides right there. Yeah. Okay, I think I've lost the class, so why don't you come down and ask me.